Welcome to Names and Formulas for Ionic Compounds. We've already discussed in previous videos how to name covalent compounds and how to name ions. So now we're going to take those names for the ions that we know and incorporate them into naming the formulas, naming the compounds. Ions with opposite charges attract each other, and ions with like charges repel each other. And because of this, an ionic compound must have at least one cation and at least one anion. Otherwise, if they all have the same charge, they'll all repel each other and we won't have a compound. So we can express the composition of an ionic compound in three different ways. The first way is by the name, so ammonium phosphate. The second way is by the chemical formula of the solid or the formula unit. So NH4, close parentheses 3, PO4. And we can express it as balanced separated ions. So as 3 ammonium ions and 1 phosphate ion. So given any one of these three, you must be able to write the other two, or you will have a great difficulty in solving problems in chemistry. So let's go through and figure out how to write each of these given one of the other two. So the formula unit contains a ratio of cations and anions such that the formula unit is electrically neutral. That is, the total positive charge must equal the total negative charge. And in order to balance the positive and negative charges, you must be able to identify the charge of the cation and the charge of the anion. That is, you must be able to identify the charge of the separated ions. In any combination of ions, whether solid, melted, or dissolved in water, the total charges of the ions must balance. That is, the total positive charge must equal the total negative charge so that the net charge is equal to 0. When deciding the name or formula of an ionic compound, then, first write the separated ion symbols. Then write coefficients in front of each ion symbol such that the charges are balanced. And a coefficient is a number written in front of an ion, element, or compound symbol to indicate how many of that particle are present. The coefficient of the cation times the charge on the cation plus the coefficient of the anion times the charge of the anion must equal 0. You can't change the charge of an ion while balancing. You can only change the coefficients of the ion. And by convention, if all of the coefficients are divisible by the same number, other than 1, then we reduce the coefficients and write them as the lowest integer ratios. So let's look at an example. Let's find the ratio that balances the charges when aluminum and sulfate combine. Let's first write the separated ions, leaving space for the coefficients. So we leave a space, and then the aluminum ion, plus, and we leave a space, and the sulfate ion. And now let's balance the charges. We have aluminum with a charge of 3+, sulfate has a charge of 2-. In order to get these charges to balance, we need 2 aluminum ions and 3 sulfate ions. So now we have 2 times 3+, so 2 times 3+, plus 3 sulfate ions at a charge of -2 apiece. So 2 times 3+ is 6+, and 3 times 2- is 6-. So 6+ plus 6- is 0. So now it's balanced. So there are 2 ways to go about balancing the charges. The first is by trial and error, and I suggest trying a few practice problems this way first. And this method can sometimes take a while. So what I would recommend is pause the video now, look in the book, find a few of the problems where you're asked to do this, do a few of these using the trial and error method first. I want you to see that this is not an easy thing to be doing. You're going to have to try a few times, you're going to make mistakes, so I suggest using pencil. But go ahead and try that now before you resume the video. The second method is the shortcut method. So in this method, you make the coefficient of each ion the magnitude of the charge of the other ion. That is, Ignoring the signs, the coefficient of one ion is the charge of the other ion. If both coefficients are divisible by the same number, that is 1, then we reduce them. So let's look at an example. Let's go back and look at this case. So this was our trial and error method, and now underneath that line, let's do the same thing, using now our shortcut method. Well, we have a charge on aluminum of 3 plus. We're going to ignore the plus. We're going to take that 3 and write it over here on the sulfate. And then the charge on the sulfate is 2 minus. We're going to ignore the minus, and we're going to write the 2 over there as the coefficient on aluminum. And you see that it balances. Now, we didn't have to reduce here because 2 and 3 are both prime numbers that are not the same prime number, so we can't reduce this. So if you're given the name of an ionic compound, you can write the separated ions by following these steps. The first word in the name of an ionic compound is always the cation. So write the symbol of the cation, a plus sign, then the symbol of the anion. Include the charges of the cation and anion. Next, add the lowest whole number coefficients that balance the charges, or you could use the shortcut method. For example, write the balanced separated ions for aluminum carbonate. So first write the symbols. So we have aluminum carbonate. Aluminum becomes Al, and carbonate is CO3 2 minus. We have to add in the charges. Aluminum, we know, has only one possible charge, so 3 plus. Carbonate has a charge of 2 minus. Now we want to write in the coefficients that balance the charges. Let's use the shortcut method this time. So aluminum has a charge of 3 plus, so let's write that over there as the coefficient. Carbonate has a charge of 2 minus, so let's write that over here as the coefficient. And remember to write the charges high on the right, and the coefficients even on the left with respect to the element symbol. If you were given the name of an ionic compound, then you can write the formula of the solid. So, in the chemical formula of the solid, the charges of the cation and anion are not shown, but they still must balance. Which means that we must first write the separated ions and use those then to write the chemical formula. So follow these steps. Using the name, write the separated ions and balance the charge. Then to the right of the separated ions, draw an arrow to the right, and after the arrow, write the symbol of the cation. Include any subscripts but leave out the charge and the coefficient for now. Then after the cation symbol, leave a small space and then write the symbol of the anion. Again, include any subscripts but leave out the charge and coefficient for now. Now put parentheses around any polyatomic ion if its coefficient in the separated ions formula is greater than 1. And now add subscripts after the cation and anion, and the subscript is the same as the coefficient in the separated ions formula. Omit any subscript of 1, and for polyatomic ions, make sure to write the subscript outside of the parentheses, outside on the right. So just like normal, it still goes low on the right of the parentheses. So let's look at an example. First, what we want to do is write the chemical formula of sodium sulfide. So first we want to write the separated ions. So sodium sulfide, sodium becomes sodium, Na. Sulfide becomes the sulfide ion, S2 minus. Remember that the charge on sodium is always 1 plus. Now we want to write the balanced coefficients. We take the charge on sodium, it's 1 plus, drop the plus, 1 becomes now the coefficient on sulfide. Charge on sulfide is 2 minus, drop the minus, and the 2 now becomes the coefficient on the sodium. We can't reduce them because 1 is already as low as we can go. Now we want to write the arrow, symbol of the cation and symbol of the anion without any charges. So we take this, copy it down there, draw an arrow, and then write Na, a small space, and S. Now we want to add our subscripts. So over here, we add a subscript of 1. If it's 1, we don't need to write it. And a subscript of 2. So add a 2 as a subscript to sodium, and we write nothing for the sulfide. Let's look at another example. Suppose we want to write the chemical formula of calcium phosphate. So first let's write the separated ions. Calcium becomes Ca2 plus. Phosphate is PO4 3 minus. Now we want to write the balanced coefficients. So we have 3 and 2. Now we want to write the arrow symbol of the cation and symbol of the anion without any charges. So we've drawn in our arrow. Now we have the Ca and PO4. Again, there's a small space in between them, so we can write a subscript. Don't forget to write the parentheses around the polyatomic ion if the coefficient is more than 1. So we'll put in our parentheses around the phosphate. And now we want to add our subscripts. So we need a subscript of 3 on our calcium, so we write that in there. We need a subscript of 2 on our phosphate, so we write that in there, outside the parentheses. So when you place an ionic solid in water, it will always dissolve to some extent. And some ionic compounds are highly soluble in water, while others are only slightly soluble in water. The ions that dissolve will separate and move around independently in solution. That is, the cation and anion are no longer bound to each other, so the cation can move around, the anion can move around. They're no longer stuck together. We can represent this dissolution process as a chemical equation, with a solid on the left and our separated ions on the right. For example, when a solid sodium phosphate dissolves in water, the equation looks something like this. So we have Na3PO4, and now we have in parentheses, we've got this little subscript S, and that subscript S is an abbreviation for the solid phase. And then we've got an arrow, and over the arrow we have H2O, so water. Over the arrow, anything over an arrow means it's not directly involved in the reaction, but we still need it around in order for the reaction to go. So the water is not reacting with the sodium phosphate, but it is necessary to have this reaction go. If we don't have any water around, we can't dissolve our solid sodium phosphate. So our sodium phosphate is splitting up into 3 sodium ions and 1 phosphate ion. And note that both the sodium and phosphate ions are now have this subscript AQ in parentheses. That AQ stands for aqueous, which means it's dissolved in water. So such a separation of an ionic compound into ions is called dissociation, because the ions are no longer associated with one another. They have dissociated. So note here that the dissociation of ionic compounds doesn't really change the ions, it's just separating them. They're no longer bound to each other. And so they've just been physically moved so that they can act independently of one another. Their charges haven't changed, and they haven't undergone any chemical reaction. To write the dissolution as a chemical equation, then follow these steps. Decide the anion's charge and its coefficient. And we decide the anion's charge first, because many metals have more than one possible charge, whereas most anions have only one possible charge. Next, we decide the cation's charge and its coefficient. The number of atoms of each element must be equal on both sides of a balanced chemical equation. And for the separated ions, the total positive charge must equal the total negative charge. These two together allow us to find the charge on and the coefficient of the cation. So first, determine the coefficient of the cation. Then determine the total positive charge. Then divide the total positive charge by the coefficient on the cation to find the charge of each cation. Now, check to make sure that the charge is balanced, and then check to make sure that the atoms of each element are balanced on each side. So let's look at an example to see how this works. Suppose we want to write the equation for the dissolution of copper sulfate. First, we want to decide the anion's charge and coefficient. Well, the anion is sulfate, so SO4 2 minus. So we can write down copper sulfate solid, and then dissolves, so yields, our reaction arrow. We're going to leave a big space for our cation, and then plus sulfate. Remember, it's in the aqueous phase. We've got a charge of 2 minus. Well, over here, we only have one sulfate in our calcium sulfate formula unit, so we can only have one sulfate over here on the right side. Next, decide the cation's charge and its coefficient. Well, the cation is copper, Cu. We know it has some plus charge, but we don't know what that is yet. The number of atoms of each element must be equal on each side of a balanced chemical equation, which means that because we have 2 copper atoms on the left, we must have 2 copper atoms on the right, so our coefficient there becomes 2. For the separated ions, the total positive charge must equal the total negative charge, and the total negative charge is the 1 sulfate ion times the charge on each sulfate, 2 minus. So the total negative charge is 2 minus. Now the total positive charge must be equal to the total negative charge, so it must be 2 plus. Now we divide the total positive charge by the coefficient of the cation to find the charge of each cation. So we have a total charge of plus 2 divided by 2 copper atoms, and that means that each copper atom must have a charge of plus 1 plus. So we'll write in the charge on our copper atom, copper ion. Check to make sure that the charge is balanced. We have 2 copper ions at a charge of 1 plus each, plus 1 sulfate ion at a charge of 2 minus each. So we have 2 times 1 plus, which gives us 2 plus 1 times 2 minus, which gives us 2 minus. 2 plus and 2 minus added together give us 0. Next, we want to check to make sure that the atoms of each element are balanced on each side. So we have 2 copper atoms here, we have 2 copper atoms there, we have 1 sulfur atom here, we have 1 sulfur atom there, we have 4 oxygen atoms here, we have 4 oxygen atoms there, so they're all balanced. So now let's turn to naming ionic compounds. When we're naming an ionic compound from the solid or from the separated ions formula, we can then follow these steps. Write the separated ions formula, write the name of the cation, then write the name of the anion, and the names of the ionic compounds do not indicate how many of each ion are in the balanced chemical formula, because you can figure that out based on what you know about the anions and cations. So make the flashcards for each lesson in Chapter 7 and memorize them. Then do the practice problems at the end of Chapter 7. And if you get any wrong, redo any relevant flashcards, review the relevant section in the book, do the practice problems at the end of that section, and redo the practice problems at the end of Chapter 7. That was names and formulas for ionic compounds.